All right, in this question it asks, what is the half-life of a radioisotope if a 500-gram sample decays to 62.5 grams in a little over 24 hours? Okay, so we're going to start with a different color. We're going to start with our 500-gram sample, which is half-life 0. And just work the table. What do we know happens? Well, I know at the first half-life, I'm going to have half of that. Second half-life, I'm going to have 125 grams, which is half of 250. And the third half-life, I'm going to have half of 125, which is 62.5 grams, 62.5 grams. Now notice something. Even if you don't necessarily know all of the steps in the process that are going to be needed, it's a half-life problem. See the wording here, half-life. So we can work the table. We can figure out, well, let's just do the halves and see where it takes us. And where it takes us is that we realize that after the third half-life, we will have the amount of sample that it's asking about. Okay. So then we know that, hey, it's going to take 24.3 hours for this process, all three half-lives, for the third half-life to have happened. Okay. The question's not how many half-lives does it take. The question is, what is the half-life? So it's asking about time. How much time does each one of these steps take? Okay. Well, if it takes 24.3 hours, and there are three half-lives in those 24.3 hours, then the answer is 24.3 divided by 3. So what is that? And I don't have my calculator with me, so that's it's a little bit more than 8, so it's 8.1 hours per half life. I'm just going to say H life, okay? And that is the answer. So let's step back and look at this. What is the half-life of a radioactive isotope for it to decay from 500 to 62.5 in 24.3 hours? Well, that's saying that you start with this sample of 500. 8.1 hours later, you have 250 grams. Another 8.1 hours later, you have 125 grams. And then another 8.1 hours later, you have the 62.5 grams. And that's it.